Hey all, good evening. We're going to talk about multiple ratios tonight. We have stoichiometry, which is the converting of one substance to another substance via a balanced chemical equation. And so we have, just to kind of further jump right in, we're going to talk about the steps. These steps are always the same. They never are going to change. Our first step of stoichiometry is to write a balanced chemical equation. So we're going to talk about writing a balanced chemical equation. That is why last unit was so important, because if you cannot write a balanced chemical equation, then obviously you're going to struggle with stoichiometry because it's step one. Step two is an if necessary. All right, if necessary, we're going to find moles. And for right now, finding moles means we're going to divide by the molar mass. But we'll talk more about that on another day. Step three is a step that you always have to do. So step one and step three are steps that you always have to do. The first thing you have to do is write a balanced equation. And the other thing that you have to do is you have to do the multiple ratio. This step right here is called the multiple ratio. And we are just converting from one step to another. What I like to use to help people remember is I like to put going on top and where we've been on bottom. So this tells me where we're going and where we've been. And this is from our balanced chemical equation, and we'll see that in just a couple of seconds. Our fourth and final step is also an if necessary step. And at this point, we're going to find whatever we're looking for. So in this case, for this unit, we're going to be finding grams. And so then we would multiply by the molar mass of that substance. But again, that's not really about today. So let's get right on down to some examples and see if we can't figure this out from there. So we've got multiple ratio examples. How many moles of oxygen are needed to react completely with 10 moles of hydrogen? So our first step is we need to write our balanced chemical equations. And I'm going to change colors quite frequently here just so we can kind of see where numbers are coming from. So hydrogen gas is H2. All right, we're going to add O2 because it says oxygen gas, and we're going to form H2O. We'll go in blue there. H2O. Now we've got to go back and balance. I'm going to put a 2 in front of H2O, a 2 in front of H2, and this is going to be 1 in front of O2. All right, so now we have our balanced chemical equation. That's step one. Step two says, if necessary, find moles. But we're given moles. So in here, I'm going to underline, we have 10 moles of hydrogen, and we're looking for moles of oxygen. So we're already at moles, so we just get to skip to step three. And this is where we've never done this before. Let me go with black so we can see how things are going. So we've got 10.0 moles of hydrogen, H2. We're going to make a handy dandy T-chart. This first box in the bottom, it's always going to be empty. Now, this step right here is where we're going to write our multiple ratio, and we're going to use our going over our been, or we could just use our balanced chemical equation. So in our balanced chemical equation, if we read that using moles instead of coefficients, 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of water. So for every 2 moles of hydrogen, note this 2 came from that 2 right there. 1 mole of oxygen is needed. So that makes sense because for every 2 moles of hydrogen, I only need half that amount. So we've got 5.00 moles of O2 is how much we need if we react 10 moles of water. Hopefully that makes sense to us, but let's keep on rolling. For this next example, it says, How many moles of water, we're looking for moles of water, are formed when 2.50 moles of oxygen react? So our first step is we're going to start with 2.50 moles of oxygen. That's what's given to us in the problem. We're going to put an X right down there. Our next step is to figure out oxygen in our balanced chemical equation is right there in purple, and we know that for every mole of oxygen, we are going to form 2 moles of water. So when we do our calculation, multiply across the top, divide by what's on bottom, 2.50 times 2 divided by 1 is 5.00. 5.00 moles of H2O. And there you have it. And last but not least, we're going to write a new reaction here. This time we have hydrogen chloride. Make it a little smaller so we can see it. Hydrogen chloride reacts with barium hydroxide. How many moles of hydrogen chloride will it take to react completely with 0.947 moles of barium hydroxide? So we still have to write our balanced chemical equation. So I'm going to put a plus there, an arrow there. We have hydrogen chloride, which is HCl. We have it reacting with barium hydroxide, Ba parentheses OH parentheses 2. One of our products is going to be HOH. It's a double displacement reaction. Forgot to put my plus sign in. And our other product is going to be BaCl2. So now we have to go back in balance. Out in front of BaCl2, we're going to have a 1. In front of H2O, we're going to have a 2. In front of barium hydroxide, we're going to have a 1. And in front of HCl, we're going to have a 2. All right, so now we have our balanced chemical equation, which is our first step. Our second step says to find moles, if necessary. Well, we don't need to find moles because we're already given moles. So we're going to say 0.947 moles of barium hydroxide, Ba parentheses OH parentheses 2. And our goal is to convert that to moles of hydrogen chloride. So if we think of it in terms of where we're going to hydrogen chloride. So on top, we're looking for HCl. So we're going to put 2 moles of HCl, and that 2 comes from that 2 right there. Where we've been is barium hydroxide, 1 mole of barium hydroxide. So we need half as much there, and that will give us our answer. All we have to do is take 0.947 and multiply that baby by 2. And so we should get 1.95 with sig figs. And that's moles of HCl. All right, thanks. Have a good night.